Welcome to the Unit 6 Section 4 video on solving by substitution. So in the first half of this unit, we have looked at one method for solving for a system of equations, and that was solving by graphing. And that is a good method to use when you have your slope and your y-intercept and you know that your final answer is going to turn out to be integer values for x and y. But if you don't have integer values for x and y, they're some sort of fraction or decimal, then graphing becomes ineffective because you can only estimate at most. You can't give an exact answer. So we need more algebraic ways of solving for a system of equations. And the first method that we're going to talk about is substitution. So the goal in using substitution is to reduce the system to one equation that has only one variable. Then you can solve this equation and substitute into an original equation to find the value of the other variable. So in order to do this, these are the steps you're going to take. You're going to solve for one variable in at least one equation if necessary. Sometimes you'll already have one or both equations solved for a variable. Then you'll substitute that expression into the other equation. So if you have y equals something, you're going to take that something and put it in place of y in the other equation. Then you'll solve that equation to get the value of the first variable. Once you have that first variable, you can plug that value into either of the original equations to find your other variable. And then you'll write your x and y as an ordered pair and check your work. So let's take a look at some examples to see how this actually works. So to use substitution to solve this system, we have y equals 2x and y equals x plus 5. The nice thing about this system is both equations are already solved for y. So we don't have any work to do in this step. Now what we're going to do is take 2x in the first equation and substitute it in for y in the second equation. So we take our second equation, and in place of y, we put 2x. Now we're going to take that equation and solve it for x by subtracting x from both sides. So when you subtract x from both sides, you get x equals 5. So now we have our x value. Now we're going to take that x value and plug it into one of the two original equations. So let's just use the first one. We'll plug 5 in place of x, and then we'll do the math here. 2 times 5 is 10, so y equals 10. And so our final answer, x equals 5, y equals 10, we have an ordered pair, 5, 10. For example 2, we are going to use substitution to solve this system of equations. Well, the first equation isn't solved for y or x, but the second equation is. So we're going to use that second equation that's solved for y, and we're going to plug in x minus 4 into the first equation. So we take our first equation, 2x plus y equals 5, and we're going to put in place of y, x minus 4. And then from here, we're going to simplify by combining like terms. So you have 2x plus x equals 3x. We add 4 to each side, so 5 plus 4 equals 9. And then we divide by 3. 9 divided by 3 gives you 3. So x equals 3. We're going to substitute 3 in for x in our second equation. And the reason we're going with the second equation here is because it's already solved for y, and that's what we're looking for. So this is going to give us less work to do. So if we plug in 3 for x, we have 3 minus 4, which is negative 1. So x is 3, y is negative 1, so our final answer as an ordered pair is 3, negative 1. In example 3, neither of these equations is solved for x or y. So what we're going to do is solve one of these equations for one of those variables. And let's take a look at the first equation. Let's solve this for x, because nothing says we always have to solve for y first. We can always solve for x first if we wanted to, okay? So we're going to subtract 4y from each side, and we have x equals 6 minus 4y. So we're going to substitute that in for x in the second equation. So our second equation is x plus y equals 3. We're going to put 6 minus 4y in place of x. And then from here we will simplify by combining our like terms. Negative 4y plus y gives us minus 3y. Subtract 6 from each side. 3 minus 6 gives us negative 3. Divide each side by negative 3, and we get y equals 1. So now that we have y equals 1, we're going to substitute this back into one of the original equations. I'm going to opt to use the second equation. So we plug 1 in for y and subtract 1 from each side, and we get x equals 2. So our final answer to this one is 2, 1. Now, in this one, we solved for y first, so make sure you put the coordinates in the right positions. Okay, x is 2, y is 1. Now let's talk about using the distributive property. Sometimes you substitute an expression for a variable that has a coefficient. When solving for the second variable in this situation, you'll need to use the distributive property. So let's solve the second equation in this example. Let's solve that second equation for x. Now the reason why we're doing this is because x is isolated. There's no number in front of it, so we can easily get x by itself. We can't do that anywhere else in this system of equations because in the first equation we have a 4y and a negative 5x. In the second equation we have that negative 4y, but x stands alone. So we're going to take that second equation, we'll add 4y to each side, and get x equals 4y plus 11. Now, let's substitute 4y plus 11 in for x in the first equation. And when we do, we're going to end up having to distribute the 5 across what we just plugged in for x. So we'll do that in step 3. Negative 5 times 4 is negative 20y. Negative 5 times 11 is negative 55. We will combine our like terms. 4y minus 20y gives us negative 16y. We add 55 to each side. 55 plus 9 gives us 64. And we divide each side by negative 16, giving us y equals negative 4. Now that we have y, we can substitute it into either equation. And I am going to opt to do it in the second equation, since x is already sorted by itself. So now we substitute in negative 4 for y. We multiply negative 4 times negative 4 gives us positive 16. Subtract 16 from each side. 11 minus 16 gives us negative 5. So our x is negative 5, our y is negative 4. So our final answer is negative 5, negative 4 as an ordered pair. There is one last topic I want to cover before leaving this section, and that is special solutions. A special solution occurs when the variables cancel while solving a system of linear equations. So if you plug in, say, your value for x, and then your y's end up canceling, and you end up with a number equals a number, you're going to have a special solution. If the numbers are equal to each other, you have a true statement, then you have infinite solutions. If the numbers are not equal to each other, you have a false statement, and therefore you have no solution. So you're going to come across some of these special solutions when you do your classwork. This is how you handle those situations. There are situations where your variables may cancel. All right, this concludes this section on substitution. Coming up in the next section, we're going to cover another algebraic way of solving a system of linear equations, and that method is elimination.